but it makes it's really nice. Sorry, it's better I do not use the device, and I'm so sorry to not open my video.
No worries at all.
All right. Oops. Still working. Okay. So hi everyone. Hope you enjoy this morning sessions, and today we're gonna have discussions with experts from University of Cambridge. We are going to talk about global data, mangrove global data. So first, I apologize. I cannot open my video because I have a problem with the video in the camera. I mean, the camera in my laptop. I'm so sorry about that, but hope you can hear me. Is it clear?
Yeah.
Yeah. Okay. So, and for all the participants, I hope you have a cup of coffee or tea. I know you have to keep a spirit because some of you have to wake up very early. Some of you maybe it's already dark, but most of you are Indonesians and you have a difficult time to come to the lecture. So I think you better provide your coffee, have a coffee in your desk. So if you feel sleepy, just sip a coffee and hope you can wake up again and focus to listen to the presentations very soon. So today we have Dr. Thomas Worthington. He is a research associate in Conservation Science Group, Department of Zoology, University of Cambridge, UK. He got a PhD degree from University of Southampton in environmental science. And then he's an aquatic ecologist doing research in freshwater and marine environments, focusing on conservations of aquatic biotas and environments at landscape and global scales. Yeah. So today we will have an important presentations because Tom will deliver his research about the just finished his work related to mangrove restoration potential, which is already provided in the website oceanwealth.org, mangrove restoration. So through this website, you can locate and maps and find out the place where mangrove can be restored or calculate the potential benefit from restorations, for example. And maybe you, as the policymakers, maybe you can provide a policy based on that data and encourage investments for from the restorations project, for example. So Tom, we have we have plenty of time for this agenda. So I think I give to you to manage your time for talk and discussions, and maybe you have any more activities during that time, that provided time. Yes, please. And then here, just for you know, we have about 40 participants from about 13 countries across the world, from Africa, Asia, and some and America, Caribbean, and most of them are from Pacific countries and countries that join in archipelagic and island states forum. So that's the participants, and maybe before I forget, I kindly request your PowerPoint so we can share to the participants later after you finish your presentations. And then I think it's time for you, Tom, to deliver your presentations.
Oh, okay. Well, thank you for the nice introduction. Hopefully everyone can hear me and can see my screen. My name is Dr. Thomas Worthington. I'm a research associate at the University of Cambridge, and I'm based in Conservation Science Group, which is housed in the David Attenborough building here in central Cambridge. So it's a collaboration of the university, but also several large NGOs who all sit together to look at science around conservation. Myself specifically, I'm funded by the Nature Conservancy, and I look at kind of global and regional scale mapping of coastal ecosystems, mostly mangroves, but also some salt marshes, and looking at sort of use we can make of those maps in terms of conservation and restoration opportunities. So I always like to start off with this slide, because I think it gives us a really good context of what I'm going to talk about. This is an image from the night lights data set, which is from the National Ocean Administration in the US. And what you can start to make out just by the night lights, and this kind of correlates with human activity, is we can see the global coastline. So coasts are highly dynamic. Intertidal ecosystems have the capacity to rapidly change their elevation due to or extent gains by migration change. Almost half the world's population live within about 150 kilometers of the coastline. So it's a heavily populated zone that has large amounts of human influence on it, which has led to mangroves and other coastal ecosystems being cleared for coastal development, aquaculture, and resource use. So what I'm going to talk to you today, first I'm going to do an introduction about why I think this is a really important topic and links into the course that you're doing. I'm then going to outline several sections of the global analysis that we currently have for mangroves in terms of primary data sets, things like extent, change and structure, things we can build off that, geomorphology or drivers of change, and finally ecosystem services. I then want to leave you with a tool that I think is really useful that you can interrogate this data and use it in your everyday analysis, research, and policy work. I'll finally finish with a talk about a new tool that I'm involved in leading on trying to capture local scale data and trying to do this link between things that we can implement on the ground with this global scale analysis. And if we have any time at the end, I'm happy to take questions or discuss certain points. So we are currently in a golden age of open data access. The picture at the bottom is from NASA, from their current suite of Earth science missions. And we've recently seen in the last couple of months the launch of Landsat 9, increasing the availability of that data. So we know now how free access or access to availability of large amounts of remote sensing data. This can be things such as the multi-decadal Landsat archive going back into the 70s, or higher resolution imagery, such as the more recent Sentinel-1 and Sentinel-2 data from the European Space Agency, and even finer resolution, the planet satellites. This kind of information has become more and more prevalent, and what we've seen is it's making headline news. So this is from the BBC in the UK, and last year Norway funded access to satellite maps from Planet to help tackle deforestation in the tropics. So that basically the Norwegian government paid for us to have access, so that any one of us can start doing analysis at that scale. That allows us to do analysis over longer time periods and at finer resolutions and spatial scales. It allows us to look at mapping those kind of linear features, such as mangroves, that we're kind of interested in this talk today. You can couple that, though, with a greater technological advancement. So we generally have greater access to high-performance computing systems, whether it be your own laptop or through big national or international or university systems. We also have access to cloud-based geospatial platforms, such as Google Worthington, which I see as part of the course outline. This is something I use relatively regularly to do some of the global scale mapping that I'm involved in. So this allows us to do rapid planetary scale data processing and analysis. And this has stimulated numerous global scale analysis, including quite a lot of work connected with mangroves. I'm going to frame the next few sections of this talk around this paper that we put out last year, titled Harnessing Big Data to Support the Conservation and Rehabilitation of Mangrove Forests Globally. And it's led by myself and multiple colleagues from around the world who are at big universities and some of the big NGOs, who are the people creating this global data that can look at conservation opportunities for mangrove forests. The key kind of figure of this paper is this one that I'm showing here. And what it shows is the linkages between all these data, these different data sets. So if we start on that top layer, in those blue boxes, these are what I like to term the foundational data sets. These are the things that we need to know in order to do analysis of conservation or restoration or ecosystem services. These are key things like the extent of mangroves and where they've changed over time, their degradation, so what their condition is like, and their structure, things like their height and their biomass. These allow us to do downstream analysis, so the things in the green circles, which relate to things we'd like to know. How fragmented are mangroves? What's caused them to go into decline? How effective are protected areas? And what's the restoration potential of the sites? And finally, in these sort of beigey hexagons are the ecosystem service values. It's really important that we can start to value mangrove ecosystems in terms of things like carbon, fisheries, and coastal protection. So these data sets are all linked together. I'm going to go through a few examples of each of one of these. So starting off at the top, in the middle, mangrove extent, probably the foundation of a lot of the analysis that we do. In 2010, Chandragiri wrote that despite the importance and significance of mangroves, our understanding of their present status across the world was inadequate. And that's been driven by the fact that earlier global land cover initiatives failed to map mangroves with sufficient detail because the satellite data they were using was of too coarse a spatial resolution. And you can't pick up, apart from really large mangrove forests, say the Sundarbans, these linear features that go along the coastline. There had been some efforts to collate information such as the FAO statistics, which were based on a compilation of disparate and kind of incompatible geospatial data sources. But there was a step change in 2010 with two remote sensing, mostly remote sensing based products. On the right of your screen is the World Atlas of Mangroves that was put together by Mark Spalding, who's my supervisor. And it's a composite extent map using remote sensing and visual interpretation for around the year 1999 to 2003. On the left is a paper by Chandragiri, which was the first globally consistent remote sensing based map for mangroves at 30-meter resolution, and it's for the year 2000. And these really provided the basis for a lot of further work that we can start to look at. But there's still a slight problem with these. There are snapshots in time. They fail to capture change, so deforestation, degradation, and regeneration. And due to the time it takes to process these and publish them, when they were published, they were already for 10 years previously. So we'd already had 10 years of mangrove change since then. We can also look at snapshots of national level data. And this is work by Dan Friis and colleague, who looked at the variability in change estimates across different data sets for countries across the world. And what you can see, there's some places such as Myanmar where there's a good consistent trend, but Cuba, for example, some of the trends are saying that mangroves were stable, some were declining dramatically, and some were increasing. And it's similar for lots of different countries. In about 2018, there was the first really globally consistent time series and change map developed by Global Macro. This was a collaboration of the University of Aberystwyth, Wetlands International, and Solo EO. And their aim was to map mangrove extent and change over a 20-year period, so from 1996 through to 2020. And it aims to provide a high-quality global mapping of mangrove extent on roughly an annual basis. It's mapped using a combination of radar data, ALOS PALSAR, and also the Landsat time series. And it's created a new nominal baseline for the year 2010. And what we can do with this data is look at lots of different things. So this is the Mahakam Delta in Indonesia, and this is the starting point in 1996, so the earliest data. You can see these big blocks of mangrove forest in green. Although there is some indication that areas have been lost, as it's a bit fragmented in the center. If we forward to 2007, you can see there's large losses in that central and northern parts. This continues in 2010, and in 2016, this is spread through into the southern part of the delta. And if we overlay where mangroves are, the purple bits are the areas that we can estimate that have been lost over time. I'm not going into a discussion of whether this development should have happened, but I think we need to balance development with conservation of ecosystems and protecting the services they support, as well as the livelihoods of coastal community. And the point that I want to make is that these maps give us the power to look at those things. We can estimate change in ecosystem service delivery, for example, losses in carbon through changes from mangroves to aquaculture, or we can identify areas that should be conserved or have the potential to be restored. So we can now see change over time. I want to slightly step to one side and talk about a different product. This is the Global Intertidal Change project that I've been involved with, that's led by Nick Murray at James Cook University. And this looks at the distribution and change of 3 intertidal ecosystems. So not just mangroves, tidal marshes, and tidal flats as well. And the point I really want to highlight is, due to the opportunities with the amount of data that we have from remote sensing, but also the processing power of things like Google Earth Engine, what we can do has the scope and the magnitude of what we can do has increased dramatically over the last few years. In order to create these maps, Nick looked at over 1.1 million satellite images from Landsat 4 to 8 missions, and it's at 30-meter resolution. And what this does is yield a spatially, temporally, and thematically consistent data set comprising of the global extent of these 3 intertidal ecosystems. And it's detailed their loss or gain dynamics over a 20-year period. What it's basically done is it's split into 7 3-year periods, so the earliest being 1991 to 2001, through to 2017 to 2019. And for each one, calculate 93 data layers And these will be things like vegetation indices, such as NDVI or NDWI, normalized difference water index, latitude, elevation. Each layer is developed at 30-meter resolution. And just to think about the scope of this, there's 7 time steps of 93 layers. And for each layer, there are 10 billion pixels per layer. And that takes roughly about 300 days to compute. So it's still a huge undertaking. It basically goes in a system of training records to data layers to 3 stacked classification models. And I'll give you an example of some of the outcomes of this. I think one of the key things with all these types of analysis is the training data that underlies this. This is based on about 60,000 training points that have been quality assured for multiple coastal ecosystem sites. And data is compiled from about 150 published sources and around about 500 hours of image interpretation that gives you an accurate location globally of where mangroves are, where tidal flats are, where salt marshes are. And that's allowed us to calculate the coastal wetland probability. And I'll give you an example in a minute. But the idea is that remote sensing analysis frequently over or under predict the extent of a single coastal ecosystem because they're complex mosaics of ecothings. So that if you put them next to each other, say you took a mangrove map and a salt marsh map, you'd either get large gaps or overlaps in independently developed maps, limiting their ability to be used in integrated analysis. What was done was that a random forest was used to predict, based on that training data set, the probability that a pixel was a coastal wetland on a scale of 0 to 100. And so what does that look like? So we're going to zoom in to one location. This is actually an example from the south of the UK. And as you can see, from the purples, they are predicting 0% chance that this is a coastal wetland, to big yellows, which are suggesting that that's really, really very likely that it's a coastal ecosystem. So you've now got the base map for doing this analysis. The next step is a second classifier was used to predict the ecosystem type of each pixel that was classified as a coastal wetland. And so this was limited to 3 coastal wetland types. There were some decision rules, so you couldn't go over a certain elevation. Understandably, we find coastal ecosystems at the coast, so their elevation is very low. The mangroves are limited within a geographic range, so there's no predictions in the UK of mangroves. We don't have any. And we use an agriculture mask to remove those areas that we know to be coastal agriculture. So if we look back at our coastal ecosystem type map, which we have here, so the yellows is what we're predicting as highly probable as being coastal ecosystems. And based on this second random forest model, we get this prediction. Again, this is for the same area in the south of the UK. And what you can see is the yellow areas are predicted to be tidal flats, and the orange areas are predicted to be salt marsh. Thankfully, there's no predictions of mangroves in this area. And this is correct, this is right. I did my PhD down this area. It's a bit large area of coastal marshes and tidal flats. So you can see that the map can pick up these different things. The next step is to look at change. I think that was the key driver behind this paper. Rather than mapping the extent of the individual ecosystems, was to look at where they've been lost or gained. And normally, the variation in the number of images per region and some limitations of remote sensing imagery can lead to kind of year-on-year variation in the mapped extent being related more to model error rather than actual observed changes. So to get around this, we developed a third classification model that sought to identify, with really high accuracy, places where intertidal ecosystems have been lost or gained. And there's a training data set of about 1,700 points that represent confirmed change in coastal ecosystems. So change map shows areas where the coastal wetlands were identified as being either totally lost over the study period or totally gained over the study period. So I'm going to show you an output from that map. We're going to go to a slightly different area because it's a bit more interesting. This is, if anyone knows, is the island of Singapore in Southeast Asia and the bottom end of the Malaysian Peninsula. And what you can see in blue are areas of wetland gain, and in red, areas of wetland loss. So I just want to look at a couple of examples. I'm going to go up the Malaysian coast and go to this, this wetland gain area in blue. What you can see, this big bank has sort of appeared during the sort of 1999 to 2019 time period. And if you overlay the year of gain on top of it, you can see at the leading edge, it started in about 2004, got bigger in 2007, 2010, 2013, right down to 2019. And what you can also do is identify what type of ecosystem has gained. So as you kind of expect in this location, it's a tidal flat that seems to have had a mangrove forest develop behind it. So you could imagine that the tidal flat developed first and then the mangroves kind of encroach from behind. If you look at an area of loss, I'm going to zoom in and go to this area down here. You can see that the map is really predicting large-scale losses in this area. If we look at what type of loss it is, it's a prediction that it's all mangroves have been lost from this area. And if we actually have a look at the imagery underneath, so I'll take off this, you can see in green we're predicting, and if you look, you can see there's been high levels of development within that region. And so that patch of mangrove forest is now no longer there. Overall, most regions showed a consistent change dynamic of losses being substantially offset by nearby gains. Lots of the change was associated with the world's deltas, which saw lots of the gains, lots of the losses as land was eroded or gained back in. Over the 20-year period, changes in tidal flats and salt marshes was relatively modest, where the biggest changes were in mangrove ecosystems. We found that there was also transitions between different ecosystems. So on the whole, about 50% of these transitions were from tidal flats to vegetated, either salt marsh or mangrove ecosystems. So in the title of the talk, I kind of wanted to move from these global scale analysis down to kind of more local scale and national scale data. And you can do this within this data set. So what we're showing here is losses and gains of salt marshes and tidal flats following that diversion of the main channel of the Yellow River in China. What you can see here in the original satellite imagery in the center, the old channel used to flow down to the southeast. When a new channel was developed, kind of in the middle of the picture, this led to a loss in those salt marsh areas, but also gains as the new channel went up to the north. So you've got the red areas that have been lost and the blue areas that have been gained. You can also see positive changes. So this is from a location that's about, I'd say, an hour and a half from where I am, and is one of the largest coastal ecosystem restoration projects in Europe. It's a really cool project run by the RSPB, whereby they wanted to sort of future-proof this area for climate change and sea level rise. You can see from the middle image that it was an area that was at one point agriculture. So what was done was to try to change the topography, and they used earth from a new railway tunnel that was being dug under London, shipped it out to this area and used it to re-profile these areas and create an area of tidal mudflat and also salt marshes. And in the blue on the left-hand side, you can see that there's been large-scale gains of these habitats, about 115 hectares, And you can see this shown up in the map on the right-hand side. And the final example that I want to give is one from the Andaman and Nicobar Islands. So in 2004, there was a magnitude 9 Andaman Aceh earthquake that caused an up to 2.5 meter subsidence across the Nicobar Islands, leading to a 90% of loss of mangrove extent due to drowning. And you can see in that middle photo, this large area of mangroves in the center, which have disappeared by that second one. So you can start to see that we can pick up these local scale changes and start to think about conservation and restoration in those areas, or look at what the drivers are. So I want to move away from the extent now and concentrate on some of the other foundational data sets that have been developed. So mangroves exhibit, as you know, substantial geographic variation in their height and biomass. And this is correlated with factors such as climate, tidal amplitude, and geomorphic setting. Initial correlative analysis linked mangrove above ground biomass to latitude and climate. So we saw bigger mangrove trees at lower latitudes and bigger mangrove trees with higher temperatures. But why is this important? Well, the variation in height and biomass affects things like ecosystem function, things like the how much carbon they sequester and store, which is important when we start to think about looking at mangroves in terms of climate change, adaptation, and mitigation. A couple of years ago, this really great paper came out by Mark Samard and colleagues from NASA, and they used a global mangrove extent and overlaid that with the shuttle radar topography mission, 30-meter resolution DEM, and also a LiDAR altimetry project to produce 2 baseline canopy height maps for the year 2000. So they were essentially looking at the top of the trees of the mangroves. So instead of going for this correlative approach, they're starting to get more derived from actual measurements. They produced a map of the maximum canopy height within a pixel, so that's the tallest tree, but also a basally area weighted height. So that's individually tree heights weighed by the proportion of their area. And that latter map was used to update our ideas about above ground biomass. And they also showed that these canopy trends were related to temperature, precipitation, and cyclone frequency. But what they also showed was there was significant structural variability at local and regional scales. So they found hotspots of tall, up to 62 meters, so that's really huge mangrove trees, and highly productive mangrove forests in the hotspots in Central Africa and South America, such as this area of really high canopy height from the Gabon estuary in equatorial Africa. So we're starting to be able to pick out the variability in the structure of mangroves at much finer resolution based on the satellite data that's available to us. One thing that's kind of really been overlooked in relation to extent is the condition of those mangroves that are left standing. I think this links in quite well with what you're looking at this week. There's been little quantification of the losses of mangroves condition in space and in time. Drivers can be things like timber, fuel wood harvesting, changes in ecosystem functions, so changes in freshwater inputs, or extreme events such as hurricanes and typhoons. The picture I'm showing in the bottom right is from an area in Brazil, where there was an infestation of caterpillars, which have totally defoliated that area of mangroves. So this would still be mapped as a mangrove forest within the Global Mangrove Watch. The structure of the trees are there. But as you can see, the condition is significantly reduced. So it would be good to be able to sort of quantify, changes in structure. And this is potentially important because it is potentially more easy to restore these areas if the drivers are removed or reduced. You haven't got these large-scale changes in, say, the topography of the landscape. There's something else that's inhibiting these mangrove forests. In order to approach this, we're again using this whole Landsat data set from the early 80s through to 2000 to try and quantify changes in vegetation indices over time. What we've done is calculate a number of different vegetation indices. So first of all, NDVI, which is the ratio of the near infrared to the red band, varies between -1 to 1. So if we look at that little schematic in the bottom, healthy vegetation reflects near infrared light, NIR, and absorbs red light. And less healthy vegetation is the other way around. So if you can start to see changes based on the relative NDVI of a location. We also used a number of different other metrics. So the soil adjusted vegetation, which is like NDVI, but minimizes soil brightness effects. We used EVI, which is used to reduce atmospheric conditions. And then the normalized difference moisture index, which is to look at the vegetation water content structure of the spongy mesophyll. So we've got 4 vegetation indices that we're looking at to see whether the vegetation of an individual area of mangroves has changed over time. So how do we do this? Well, again, this is all done in Google Earth Engine, and we would not really be able to do this without a large-scale computing structures, but I can basically do this from my laptop. We apply a vegetation indices to each pixel of each image. We then repeat that for all the images in the collection, and as we've shown from Nick's work, there are at least hundreds of thousands of these images over the time period, and then split them into 3 yearly periods, so from T1 to T12. So every 3 years, we take all the images available. And then for each time period, we just reduce that to a single value, either a median or a trimmed mean. And what you can do is very simply just plot those vegetation medians over time. And this is just a made-up example. But for example, for this pixel in space, what you can, in time, you can see that there's been a change in the vegetation indices over time, which suggests there's been some decline in mangrove condition. And so I'm going to show you, this isn't published yet, I'm just in the process of finishing this off, some of the initial maps that we have created. So hopefully this loads in, again, in Google Earth Engine. So this is in central West Africa, in Guinea-Bissau, not too far from Conakry. The red areas are mangroves, so that's the current area of mangrove extent. And as you'll see, as the new layers get drawn in, we're getting an analysis that's showing more and more degradation over time. So you can see the time series coming in. And in purple are those last layers is when we have degradation in 2017. So you can see high levels of degradation in that location. And if I remove some of the layers from behind it, so that's where mangroves are now. The purple bits are the ones that are degraded. And if I remove this behind, you can see high levels of degradation and potentially some loss within those areas. So we are seeing real on-the-ground changes associated with this structure of mangroves. Secondly, we can look at lots of other things. The data set's pretty rich in terms of what's available. So in the top left is the condition change. So the browns are areas that have declined. So we can see from this island there's large amounts of decline. The greens are areas that actually regenerated, so we're getting some regeneration. We can identify the number of events, so how many times they declined over time, and I think this is going to be important when we look in particularly the Caribbean and the Americas, where you're getting large-scale changes due to things like hurricanes coming in, defoliating the mangroves, and then coming back, and then maybe that happening again. There's also the maximum degradation, how badly and when did it start. So you can see all these different things from the data set. Okay, so I've been talking for about 35 minutes. What I want to do now is just take a very kind of have a little bit of a quiz. It's really very simple. It's like, don't worry about getting it right or getting it wrong. It's just a bit of fun. But what I'm trying to show is that the data that we have is so comprehensive, we can really start to map changes in coastal ecosystems and coastal zones at really high resolution. So what I'm going to do is show 4 videos of locations from around the world. And if anyone wants to suggest which of the 3 cities that I put down at the bottom I'm showing, just either put your hands out or just unmute yourself and shout out. So, is this map of Osaka in Japan, Shanghai in China, or Jakarta in Indonesia? Does anyone want to have a go?
I want to go with Osaka, Japan.
Well, fantastic. Yeah, this is Osaka in Japan. And what you can see within this area is that there's been high levels of land reclamation that's likely to have had a large impact on the coastal zone. And you can see that actually probably a lot of this happened even before this time series available. So, this area is a highly, highly developed location that's lost probably quite a lot of its coastal ecosystems. Okay, anyone want to have a guess for this? Is it Spurn in the UK, which is probably 3 hours for me? Is it the Barrier Islands of Sylt in Germany? Or is it Cape Cod in the US? Anyone want to guess? Sorry, what?
The USA.
Okay, yeah, again, very, very good. So yeah, this is Cape Cod, and what you can see is this is, as I said at the beginning, highly dynamic. Changes with longshore drift coming down, new rivers getting pushed across, new breakages, and this is really impacting the location of these tidal flats and also these salt marshes. But would be really interesting to know and to think about when we think about, how we can manage these areas. Is this natural or is this human-driven changes? These are questions that we need to be able to answer before we can really say, well, actually, we need to do a conservational management intervention in this location. Okay, I love this one. This one I think is amazing. So this is either the Meghana River in Bangladesh, the Yangtze River in China, or the Mississippi in the USA. Anyone want to guess on this one? You can see sorry,
this is from Bangladesh.
It is, exactly. It's from Bangladesh. Brilliant. You can see, this development of mud flats and then mangrove forest, particularly in that kind of bottom left-hand corner coming in. And this is a real challenge when we're trying to do global mapping of change over time. It's these areas that are super dynamic, trying to map that's changing. That's, not a huge amount of time that's changing over. And so trying to work out what's driving those. Do we need to be concerned? Is it natural changes? Is it human-driven changes? So yeah, brilliant. I think you're 3 from 3, and I would guess that most people will get this one. Is it Doha? Is it Dubai? Or is it Kuwait City?
It's Dubai. It's Dubai.
Yeah, it's Dubai. Just amazing developments along the coastal zone. You can see the palm tree, you can see the islands of the world, and actually you can see right in the center there where that kind of inlet lagoon is, they've cut a new bit through, there's a new development in there, and that's one of the areas of mangrove forests in that location. So that was just a bit of fun, and I really wanted to, sort of break up the talk a little bit, but also just to give an indication of, how the scope of the data that we have in order to look at changes within the coastal zone. You can do this for any part of the world. So thank you for everybody who played along. That was really great. Okay, so I'm going to go back to this diagram. So we've looked at these blue boxes across the top, and these relate to those foundational data sets. I now want to go on to the green circles and talk about some of the things that we can develop based on those analyses. So there's been a real concerted effort within mangrove to look at different classifications based on their geomorphic setting. So on the left, we see the work of Robert Twilley and Rivera Monroe, who mapped this as a hierarchical structure. So at the top, the global distribution, driven by temperature, 25 degrees north to south. Next step down, you've got this geomorphic environmental setting, so whether it's deltas, oceanic islands, lagoons, or estuaries, and then the ecological type, whether it's scrub, basin, within those kind of estuary areas. Similarly, some similar work by Colin Woodruff and colleagues, also looking at kind of river deltas, tidal estuaries, and the like. Our aim was to try and map this, sorry, I'll just nip back, to try and map this geomorphic type, these large-scale, macro-scale units. So we wanted to try and identify deltas, estuaries, lagoons, and something we're calling open coast mangroves related to embayments. So how did we go about doing that? Well, first of all, we took a high-resolution coast map and just identified the coastline at high resolution around it. And what I hope you can see is that some of the features start to pop out immediately. So right in the top, in the middle, you can see the big Niger Delta in the center. To sort of above it and to the left, you kind of probably can pick out some of the lagoonal areas. And down in the south, you can also probably pick out some of the big estuaries. And essentially what we did was just shorten the coastline. So we went round and cut off those polygons to give us geomorphic setting polygons that we could start to classify. So again, you've got the delta in the middle, and then highlighted is a big lagoon in the center, and then down to the south is one of the big estuaries. So we needed to think about how we would categorize those and split them into different groups. So one of the things we looked at was, well, the shape of these is quite different. What they look like is very, very sort of different between the different types. So we came up with 10 different metrics that kind of tried to capture the shape of those polygons. Simple things like their area or their perimeter, but the number of ocean outlets shown in the purple at the top. As you can imagine, deltas have lots of outlets to the ocean, so you can start to sort of identify where the deltas are. The length ratio is just a term for the ratio of the outlets, the bit where the polygon meets the coast, and its width. And you can see that actually lagoons have a really small mouth, but really wide. The estuaries, for example, are perpendicular to the coastline, where the lagoons are much more parallel. And also we looked at the size of the catchments and how much precipitation. So we took together all these different sources of difference between the polygons to try and categorize them. And what we did was run a random forest to assign polygons as estuaries, lagoons, and bays. And actually what we thought would likely happen actually turned out to work quite well. So for example, there was much more precipitation coming to the estuaries than other types. They were more perpendicular to the coastline and so forth. So we could start to categorize those polygons into their geomorphic type. So as you can see, we've picked out that big polygon to the top is a lagoon. We've identified the delta in the middle. We've identified some of the estuaries down in the south. And simply what you can do then is overlay where the mangroves are in that area and then just assign them to the polygons that they're close to. So now we have a geomorphic representation of different mangrove types. So why is this important? Why do we go through this whole process? It's an interesting academic exercise, but it has some really sort of practical implications. Well, first of all, and maybe one of the most important things, it provides a framework for looking at variability in mangroves globally. So we can look at mangroves at the global scale. We have the global scale data sets. We can look at them within continents. We can look at them within countries. But those two things are based on political boundaries and not really kind of geomorphology or biology or ecology. These are based on geomorphologic type and are a finer resolution, and they allow you to aggregate areas of mangrove together into sensible units. It's also important because different sort of types, so deltas versus lagoons, have different restoration considerations. You wouldn't restore them in the same manner. And finally, ecosystem function differs between different types. What we found was that the above ground biomass was lowest in the lagoonal areas, then in the open coast, but highest in those deltaic or estuarine zones where there's large influx of terrigenous sediment. And those mangrove trees get bigger, as you would expect. And some similar work by Robert Twilley and Andre Ravai found that this environmental coastal setting, they used a different type to ours, but showed that soil organic carbon changes across different coastal environmental settings. So if we want to start trying to identify where ecosystem services change and how variable they are, we need to know what the geomorphic type is below. I'm going to move on now to another important factor, which is the drivers of change. So understanding the drivers of loss can support management interventions. And until recently, the availability of information hampered our ability to do that, which was generally either regionally specific or at a coarse scale. That was until this really excellent paper by Liza Goldberg and colleagues from NASA, who looked at human-driven mangrove loss across the global extent. And using machine learning, decision trees and cloud computing, again in Google Earth Engine, they mapped the drivers of mangrove loss into 5 categories. Settlements, so that's urbanization, commodities, which is things like a combination of rice, shrimp, aquaculture, and oil palm, erosion, non-productive conversion, which is kind of land clearage and maybe mining, for example, and extreme weather events. And this looked at changes over the year 2000 to 2016. So there's quite a lot going on here, and I'll unpack it in a minute, but human activity was the primary agent of change between 2000 and 2016. However, that human conversion actually declined quite significantly over the 16-year period, suggesting that we're having some impact in reducing human-driven mangrove losses. The vast majority of the decline due to anthropogenic loss, about 80% of it, was in 6 countries, which are Indonesia, Myanmar, Malaysia, Philippines, Thailand, and Vietnam, and 80% of those changes. So what you see at the bottom is the main drivers for the different kind of continental groups. So C is Central and North America. The main drivers are extreme weather and erosion, with some non-productive conversion. Similarly for Oceania, which is G. We see more commodities in South America, but again, mostly erosion driven. But it's in E and F where the large-scale losses due to human activity were. So F is South and Southeast Asia, are really driven by commodities, things like oil palm, rice, and shrimp agriculture. Whereas in Africa, it was conversion of land, but also much more urbanization than we saw in other locations. The final one in this section I want to go on to is some work that I led on restoration. There's been significant efforts to map mangrove extent, increase mangrove extent through restoration and rehabilitation. And we were tasked with creating a restoration potential map. And what the aim was to identify a national scale restoration potential for all the countries in the world. The aim was to highlight areas where restoration is more or less feasible, and also link that to ecosystem services to highlight potentially high gains from restoration. And we based this on those typological units that I showed a few slides ago. So we were calculating the restoration score for an individual delta, an individual estuary, or an individual lagoon. So we're actually at a finer resolution than individual countries. And it was based on an expert-derived model for restorability. So we incorporated 7 driver variables, and we're just in the process of redoing this, so it's going to be a new version coming out, hopefully in the next couple of months. So we looked at tidal range, future and historic sea level rise, whether there'd been a change in the sediment regime to the area, but also things related to the patches of loss themselves. So how big they were, how contiguous they were with the existing mangroves, and when they were timing if they were lost. And what this gets you is an individual scorecard for each mangrove area in the world. So this is for an estuary in West Africa. And this just shows the maximum mangrove area between 1996 and 2016, how much is restorable, what's its restoration score, as shown in that little wheel to the right-hand side, but also the ecosystem service values for the restored mangroves. And this data is available to look at and interact with, so I'll just show you what it looks like. So when you launch it, you get the global analysis in terms of the total area of restorable mangroves, what percentage of that's restorable, and the global values in terms of ecosystem services. But you can interrogate this in lots of different ways. So I'm going to go to an individual area. So I'm going to go, given that we're being hosted by Indonesia, I'm going to go to Southeast Asia. And what you can see is that it actually redraws the map, zooms in, and recalculates all the statistics for that region. So you can see you get different values. What you can also do is color the map in based on some of the key factors. So if you click on that, hopefully it draws in, you can start to identify areas that are more or less restorable within the mapping extent. So you can start to make decisions at this scale already. Obviously, you need to go onto the ground and do really in-depth local scale analysis. But at this macro scale level, it's giving us an indication of which areas have the potential to be more or less restorable. You can also look at some of the ecosystem service values. So, for example, soil organic carbon, if you overlay that and redraw the map to show where the areas with the highest soil organic carbon are. We can go a couple of areas lower, so I'm going to go to Indonesia. So I click there, it just redraws, it just moves slightly, and it recalculates for just the country of Indonesia. So you get national level statistics. And finally, you can zoom in to even finer resolution. And if you watch this dashboard here, this changes in a minute. So I clicked, and now I'm just highlighting that individual delta. So that's giving us a restoration score for that. It's telling us what the data that went into it here in terms of the 7 variables that I talked about, but also gives you individual ecosystem service values for that. So you can get like a hierarchical level of data analysis. So overall, we found that there's a roughly 8,000 square kilometers of restorable mangroves. And as I said, this is being updated, so that number will change over the next couple of months across 105 countries and territories. And this will also change because there's a new base layer from Global Mangrove Watch, which has mapped a few of the countries that were missing originally, such as Togo and Peru. Okay, I want to go on to the final lot of global analysis, and these relate to ecosystem services. So these are these beige hexagons to the right. And as I'm sure all of you know, mangroves are a poster child for ecosystem services. They support a range of valuable services, including climate mitigation, biodiversity maintenance, coastal protection, fisheries enhancement, and tourism. But the full value of mangroves is often not captured in development policies or funding mechanisms. Global institutions such as the World Bank have started developing frameworks and approaches to to include monetary value of natural capital within national wealth accounting systems. So it's really important we can start to calculate ecosystem service values for different coastal ecosystems. There's been quite a lot of work within mangroves around mangrove carbon. Mangroves store and sequester large amounts of carbon, roughly 4 times the amount that some of the tropical forests. So there's been multiple modeling approaches to calculate either soil carbon, as shown by the Sanderman paper on the left-hand side, or above ground carbon, as shown by Mark Samard's work on the right-hand side, or just total carbon. And these use different approaches. So, for example, Sanderman et al. In 2018 looked at fine-scale 3-dimensional variation using machine learning approaches, highly data intensive. Atwood and also Revi looked at how soil carbon stocks vary across things like latitude, hemisphere, community composition, or geomorphic settings to provide correlations and show the variation that way. Or for above ground biomass, Twilley and colleagues use latitude, whereas Mark Samard and colleagues use related that to the LiDAR data and height data that I showed earlier. So there's quite a lot of different bits of soil carbon analysis that you can start to look at. But what you have to be aware of is that these are very different approaches. So will yield different global statistics. They have underlying data sources, underlying different models, and use different, often mangrove extents. But I think the data is really important and can start to be used within the country's NDCs, part of the Paris Climate Agreement. Okay, I'm going to skip on to fisheries. This is some work that was led by Lena Zuermgassen, who used to be here and I've worked quite closely with. So mangroves are critical nursery habitats for fish and invertebrates. And they support large numbers of mangrove-associated fishes. What we tried to do was identify the drivers of small-scale fisheries in mangrove habitats through a 3-round Delphi process, which is shown by the diagram at the bottom. So a group of experts were asked to score identify the 20 most important factors that determine the volume of fish and invertebrates that you catch within a mangrove ecosystem. They were then asked to score those importance of those factors between 1 and 5 in Delphi's 2 and 3, as either being not important or extremely important. And the mangrove fisheries we were looking at were the crab, which is in mangrove fisheries, or nearshore artisanal subsistence fisheries, which is the person throwing a net from a boat. We didn't look at nearshore commercial or offshore commercial fisheries because the factors driving those are very different. We then translated this conceptual model based on available consistent geospatial layers that can map the quantity and quality of each factor. And these were distance to mangroves and other fishing areas, local non-urban populations, and accessibility to markets, and finally catchability as a result of weather. So we put these 4 things together in a geospatial model and mapped the amount of mangrove fishes globally. And what we come up with is this map where we estimate that globally there are 4.1 million people associated with small-scale mangrove fisheries globally. So a hugely important resource for coastal communities. The highest number of mangrove fishes were found in Indonesia, India, Bangladesh, Myanmar, Brazil. So really concentrated in throughout Asia and to a lesser extent, West and Central Africa. But we also found some areas where they made up a huge proportion of the national fishery. For example, in West and Central Africa, mangrove fishers made up about 95% within Guinea and Guinea-Bissau of the total small-scale fisheries. Okay, so I've gone over a raft of different global data sets. A lot of them are outlined in that paper. If you want more information, I'm sure they'll be fine to send that paper around. It's completely open access. If you have any trouble, do send me an email. I'm happy to share it with you. What I want to talk about now is a tool for starting to interrogate that data. So what's been developed is the Global Mangrove Watch platform. And the platform seeks to emulate the success of other data sharing or advocacy platforms such as Global Forest Watch or Global Fishing Watch. These platforms kind of are new conduits between data producers, people like myself, who are trying to maximize the benefit of their work and their analysis, and people using the data who are trying to use it as part of their scientific analysis or their decision-making process. And what it gives you is access to interpreted data, trying to empower communities, NGOs, and scientists to undertake practical conservation and rehabilitation actions. We've aimed to enhance and harmonize the different data sets so that they're aligned based on the base foundational data layers and they can work together. Where in the future, we'll probably be looking at incorporating data sets within regional and national extent, because these may be more accurate for on-the-ground management, and also allow users to display information relevant to their situation. So if I go to the tool, and this is freely available, I can share the link with you in this. So as you launch in, this is the global extent that you're shown here. I apologize, the screen on this computer at work is a little small, so it's all a bit cramped in. But what you see is the global extent, and it shows you outlined all the countries that have mangroves in them, shown in yellow out to their EEZ, so their kind of total area. And in green, the mangroves have been expanded in size, so they sort of stand out because it's difficult to map them globally. On the left-hand side, we have these what look like cards. These are called widgets, and they show you the data that's being viewed. So currently, we're looking at habitat extent. I will just turn on the change layer. So what we're getting is the change in mangroves globally between 1996, and it's identifying that about 6,000 square kilometers were lost. If we zoom into certain locations, if we go into this area in West Africa, you'll start to see, as it zooms in, it starts to redraw over the top. And what you can start to see is things like where mangroves have been lost. So we've got a lost area of mangrove lost down here at the back. I'll zoom back out. There are some more data sets that are coming very soon. This is in process of being changed as we speak. But we do have information on ecosystem services in terms of carbon. So this is the total carbon density, and you again shows you the global value. And you can again just turn on that data layer. What you can also do is start to look at individual countries. So I'm going to go back over this way. And this time I'm going to go to India. And I'm going to click on India. And what you'll see is that it recalculates and gives you the statistics for India. And it will do the same for all the different data widgets that are shown. So you can start to get national level data. And this is some like the cutting edge science that's available in terms of mangrove extent or mangrove carbon. So we try to wherever you use the best data sets available. We're hopeful in the future that you'll be able to draw your own polygon around an area and extract that data for the bit that you want. But what you can do is just click on this download a report. I apologize, this doesn't look as great as we're hoping for, but it is in the process of getting changed. What you get is global statistics for carbon being put into the PDF in terms of for India. So you can start to export that data. So I'll just cancel that back out. And we'll just go back to the global layer. Turn that widget back off. There's just one more data set I want to show you. And this is going to link into what I'm going to talk about next. This is mangrove alerts. So these are alerts suggesting where there's been disturbance between January 2020 and October 2020. So if I just turn them on, it's only operational currently for Africa. It's hopefully going to happen throughout the rest of the world. But what you can see is, these off, you can start to see these hotspots of mangrove disturbance based on the satellite imagery. And then as you zoom in, it gives you a more in-depth picture from these locations. And this is really useful. You can start to identify areas that are changing in almost real time. It's pretty, up-to-date information. This led to field teams from Worthington International going to the field to identify why there was this big area of loss in one of these places in Guinea-Bissau. And it's actually related to an area being cut off and the mangroves being cleared for rice aquaculture. But you can start to identify, and maybe if it's viable, put in conservation or restoration activities based on this real-time data. As I said, this database and this data platform is being updated as we speak. It's based on funding from the Global Mangrove Alliance, which is a collaboration of multiple global NGOs around this idea of increasing mangrove area and increasing mangrove conservation. And so if anyone has any questions, do reach out. I'm happy to give you more information and kind of try and highlight when more things will become available. We are hoping to put on more ecosystem service values, but also some of the restoration stuff as well. Okay, I'm going to finish off with moving scales completely from big global scale analysis to much more local scale analysis, but hopefully done at the global scale. So I'm going to talk about what's called the Mangrove Restoration Tracker Tool. It's shortened to MRTT for ease throughout the rest of the presentation. That's what I'm talking about. So mangrove restoration is supported by numerous global targets and initiatives. So by 2020, we were supposed to bring 150 million hectares of degraded or deforested landscapes into restoration as part of the Bond Challenge, and that included mangroves. The Global Mangrove Alliance, its collaboration of multiple NGOs, has a target to increase mangrove cover by 20% by 2030. But the question I always raise is, what progress are we making towards global restoration targets? I think we know where mangroves are changing in terms of their extent. We know areas that are being lost, and we know areas that are being gained. But I don't think at the moment we can really pinpoint globally and consistently which of those are being driven by restoration. What the aim of this tool is to record individual restoration projects and map them at a local scale, but do this globally so we get a global overview. But this is not as easy as it would seem. There's a general lack of reporting, and many mangrove restoration projects do not report the results. And if it seems likely that projects that fail to report their results are often ones that have been unsuccessful, the restoration community loses a valuable opportunity to learn from past mistakes. If I go back to this figure, what you'll see is from case studies that were put together by Yasmin Gat, who is a PhD student at the National University of Singapore and was a visiting master's student here at Cambridge. She identified mangrove case studies from the published literature. And you can see hotspots of case studies from Southeast Asia. You'd expect that. There's large amounts of mangroves there, and we've seen large amounts of mangrove loss. But we see a real underrepresentation in Africa, and we know restoration is taking place there. So this information is not going into the literature that we were looking for. And this is partly because the information is scattered across different media. So it's on websites, through literature, and published papers, which makes consulting the evidence for decision-making extremely time-consuming and repetitive in terms of everybody having to go back to the same data sources. Also, the data are extremely variable in terms of extent and also quality. Even where mangrove restoration outcomes are known, the type of data reported are extremely variable, with key aspects such as costs or measures of success largely lacking. So again, this is a figure from Yasmin's work. And what it shows is the categories of different bits of information. So costs, cause of decline, interventions, so forth. Don't worry too much about the detail, but what we would hope for is that it was all dark green, which would mean that all projects highlighted all of those things within their reporting. But what you can start to pick out is there's lots of areas that are light green, suggesting that they're not captured within the literature. So, for example, pre-restoration measurements are not well captured. Neither are some of the social aspects. And what we're trying to do is create a resource that collates all this information on mangrove restoration projects that we know are happening and give practitioners a critical tool that would aid improved restoration practice. So this is underpinned by a standardized framework, and we're trying to create a globally accepted standard. We are trying to create a culture whereby this data is the standard thing to record. So we're trying to make it easy but comprehensive enough to complete. So there's a number of questions with predefined answers that allow users to go through and quickly fill in this data. And we're trying to be inclusive of different expertise, backgrounds, and geographies. So this is just a plea for me. If anyone's involved in restoration of mangroves and is interested in getting involved, we're really keen to collaborate with people. We currently have a team of probably, it's somewhere in the region of 70, 80, maybe 100 people involved in this project. So the tool itself is split into 3 different sections, which are completed at different stages. So the first of all is the registration phase. This captures things like the location of the project, who the partners were, what its aims were, and what some of the causes of decline. And we would envisage this being completed during the planning stages of the project. Secondly is the interventions. What was done? Was it planting? Was it hydraulic restoration? What kind of community activities were undertaken? And finally, how much did it cost? And we would suggest that this would be completed after the project activities were done. And finally, there's several sections related to monitoring, both socioeconomic and also ecological, that can be completed multiple times. So I'm just going to run through how this fits all together. So initially, there's a simple web form for capturing this data. And as I said, it's a bunch of predefined sections with predefined questions. So for example, we just asked, what's the overall aim of the project? Are you trying to restore or rehabilitate an area? Are we trying to reforest it, or are we trying to protect it? And it's just a selection of multiple choice questions. We're also going to create sort of offline versions that can be taken in the field in multiple languages, and have PDF guides to data entry linked to best practice guidance in multiple languages. And we're hoping to develop some training materials through the GMW platform. This leads then to data storage, so we then have this data within a data repository, and then individual users will be able to log into the Global Mangrove Watch and export all their data from their projects to a simple CSV form. So you can imagine if you're a big NGO, you have lots of projects, you enter all the data in, and then you can export it back out in a standard form. And then this will allow us to also create project reports. So this is going to be an output, a PDF document on the individual project details. There's about 4 to 5 pages and a mixture of text and graphics. So I've just made an example up from Kenya. This is completely made up information. So we can say, take the name of the project, when it was carried out, who were the partner organizations, and what were the aims of the project, to create this narrative that explains the information. And as you put more details in, the document gets updated. But we think this will be really useful for communication with both stakeholders, but also with funders in terms of showing people what they've done. And you can imagine you could get figures that show, for example, the change in mangrove area over time as you go back and monitor it more and more times. Then this is going to be linked to the GMW platform in order to display this data. And we envisage it just being a selection of points around the coast where restoration projects have taken place. But if you're interested in planning a project, you'll be able to filter projects that have similar methodologies, similar aims, and so forth. So, for example, if you want to restore hydrology, you can look at the 3 projects that really relate to what you're doing. And again, there'll be pop-ups that show you key project information. Again, I've totally made this up. For Minna Creek, it's actually not where that's not the location of Minna Creek. But you know, taking key information from the data input to try and capture that information. So, how much did it cost? What was the partners? What was its aims? We hope this will allow other practitioners to see kind of what the best practice is. And finally, we'll be able to then synthesize this data at national, international, or global scales and provide a much better answer to that question of how well are we addressing restoration targets. So why get involved with this? Well, we think there's a number of reasons why we'd like people to get involved. We think this will help stimulate best practice mangrove restoration. So support practitioners identifying the key steps for consideration and the key indicators to track when you're doing a restoration activity. We're going to embed the framework as a step-by-step guide on the factors to consider when doing restoration and embed that within other tools on restoration best practice. So guidance documents highlighting, you know, the benefits of planting or hydraulic restoration, you know, the comparisons of those two different things. We want to also make it easier to record monitoring outcomes. We hope by displaying this data, it will highlight the benefit of long-term monitoring and monitoring a wider range of ecological and social outcomes. And we're going to encourage funders to see monitoring as a critical part of restoration. With accurate location, we can also monitor area change remotely and feed this back to the project. So I know working on Google Earth Engine, you'll be able to immediately take the satellite imagery if you have the polygon to say, okay, mangroves are changing there. We're having positive outcomes. It also allow users to visualize and compare with other projects that have similar underlying conditions. And you'll be able to look at similar approaches, similar aims, and so forth. But we can hope that these outputs from the tool will provide useful information for funders and communication about the project. And really importantly, I think this data can help showcase positive stories around mangrove conservation and restoration. This idea of conservation optimism. There's lots of fantastic work being undertaken, and we really need to show people what we can do if we follow restoration best practice. And it will also allow rapid synthesis of global restoration effort and success. So it collects standardized data to increase learning opportunities from successes and failures related to mangrove restoration projects. Again, we hope this will improve restoration best practice and stimulate best practice overall. So I'm just going to wrap up with a couple more slides. As I've shown, there's a lot of global data out there that we can start to look at in terms of mangroves, mangrove extent, condition, and structure. Some more analysis we do from there based on, you know, fragmentation, geomorphic type, or restoration, but also starting to look at, you know, the value of the mangroves themselves. So just to finish off with, I think we're in a golden age of open data access and technological advancement. This has stimulated a lot of global mangrove analysis. I've gone through a couple of examples. Again, there's more details in the paper. Please, you know, have a look at that if it's of interest. And tools are being developed to interact with that data, put it in the hands of scientists and NGOs that want to use that data to make decisions on the ground. Where we're kind of, the next step is to make sure that we link very clearly that global data to local implementation. And if I would say a final thing, is just that there are lots of people out there working on these sorts of questions. So if you have any questions around these, I would encourage you to reach out and collaborate with scientists. I found that the mangrove community is super welcoming, with lots of great scientists who are really keen to help. Just finish with some acknowledgements. I'd like to thank particularly my funders, Mark Spalding and Emily Landis at the Nature Conservancy, but also my supervisors, William Sutherland and Andrew Barnford here at Cambridge. Loads of people, as you can see, I collaborated with on the mangrove restoration data sets, but also Nick Murray for the global intertidal change data set, And finally, Yasmin Gatt and Dominic Andrade Brown at WWF on the mangrove restoration typing tool. If anyone wants to have a look at any of those data sets, here's the link to the restoration one and also the Global Mangrove Watch. And also my email if anyone wants to reach out and has any questions. But thank you very much for listening, and if we have time, I'm happy to take questions. Thank you.
Yeah. Thank you very much. Thank you very much, Tom. This is very interesting topic to talk this afternoon in Indonesia, in the morning in your country. But I saw many faces very excited to your talk. I think there must be many questions. So please, for the participants, if you have any questions, please raise your hand or you just jump and ask the questions, please. Any question? Oh, yeah. I saw Diana. Yeah, please, Diana.
So you're muted currently.
Yeah, you're still mute.
Thank you. It was a very interesting presentation. I have one question that I'm curious about. There's an example on the high number of disturbance alerts that you show me in one of your slides. Made me wondering like how they are measured and what type of disturbance that are observed. Because the number is high within a short time period, but I just wonder how they measure and what kind of disturbance that are observed from that site. Thank you.
Thank you, that's a great question. So when you go to the initial disturbance alerts, they're aggregated so that it look quite a large area. As you zoom in, they become more disaggregated, so you can actually pinpoint. So they probably look bolder to start with than they necessarily are. It's based on changes in satellite imagery. So it's looking at regular changes in different metrics within the satellite imagery. And I think I'll have to check back, but I think it's based on the Sentinel data. So maybe the Sentinel radar data, which is a finer resolution and often quite regularly repeated. And it's just looking at structural change in the mangroves. So unless you went to the field, you wouldn't be able to determine what were the drivers of that change. So in the example I gave you, Guinea-Bissau, it was I think the area was cut off hydraulically and then converted to a rice agricultural area for food. But what it can do is show you an area that maybe is of interest. So you can start to think about, okay, we need to have a look here. And you might go to the field and see, actually, this is an agricultural area, that's fine. Or it might be something that you can do kind of conservation in or kind of try to improve on. It is very much hopeful that this will be done throughout the global extent. At the moment, it's just being showcased for Africa. But it hopefully will give some kind of more up-to-date information to you, because it takes a time to process all this information and then get it published and get it checked. So by the time it comes out, we've already seen some of these losses already. So that's the driver behind that. But thank you for the question.
Thank you, Ka.
Yeah. So next questions from Rulio. Rulio, please.
Hey, very good presentation. I do have a couple of questions. So I'm from Antigua and Barbuda in Caribbean. I'm just curious to know how useful or how usable I think these websites are on these smaller scales. Normally it is looking at a large geographic area, but for a country like Antigua or the countries in the Caribbean that have a pretty small geographic scale, I'm very curious to know what's the functionality, and then also in terms of what data sets are they pulling from in terms of being updated, etc. Just didn't know if you could shed light on those two questions.
Yeah, that's a brilliant question. And you raise a really good point there, that I think if we think of countries like Indonesia, these global scale data sets are probably closer to the national scale level. You've got to think that, you know, you're making decisions at the global scale that you're trying to get it right globally, which means that local scale can be not always 100% correct. And that's particularly problematic for some of the smaller nations who've got really small mangrove areas. So the Caribbean islands particularly, I think, are good to highlight. I think what I would say is that, you know, in those instances, it's important to look at the data and see whether you think it answers the questions, and if not, then there is quite often finer resolution data that can actually answer national scale questions. I know there's been quite a lot of mapping for some of the small nations, but it's definitely, yeah, it's a very good point that, you know, that those big global data scales are a global representation and should be seen as such. In terms of pulling the data, the extent maps are from the GMW data set, so they are hopefully going to be updated every year. Maybe as we move into the future, that they will be, rather than the 25 meter resolution data they're based on, there'll be 10 meter sentinel data, which then starts to be better for smaller areas because we've got a more accurate data set. The other data sets is a range of different sources. So the carbon data, I think, is a comparison of the salmon and soil data, but also the CIMARD above ground biomass. One thing I always think is, you know, we have the data. Often smaller scale, more local studies can be better at that, are better at that scale. But sometimes if you don't have them, the global scale analysis may be the only thing that you can start to get an indication from. It will be updated lots of times, so we're putting more information on there. But you're exactly right that, you know, it's important to check the data at a kind of local and national scale and try and see whether there may be a better data set for you. Thank you, that's great.
Yep. So, any more questions? No? Pak Wayan, you said you want to ask something. Pak Wayan. Okay. Is there any more questions from the participants? I think there are a lot of information and knowledge we have learned this afternoon here. So please, Diana again, do you still have any questions? Yeah, please, Diana, please. You are still on mute.
Okay, thank you. So in this big data from the global watch, the global mangrove watch, what is the policy of the data collaboration or data sharing when we want to compare, like one case from Indonesia, mangrove rehabilitation in Indonesia, and we want to compare with the other region, for example, Bangladesh? What is the policy of the data sharing if we want to compare data from 2 or 3 regions?
Yeah, so for underline the baseline data, at the moment you can look at individual countries. You would have to basically click on Indonesia, click on Bangladesh if you wanted to get that piece of information. We do hopefully are going to put in tools where you can draw your own areas to select the bits of data that you want and then export that data. Most of the data that's produced is freely available anyway.
Okay.
So the Global Mangrove Watch data set is downloadable from the UWC Ocean Data Viewer. The typology that I created is available. The restoration map's not available yet, but will be. We will have download capabilities. One thing that might be of interest is if you share the paper with the participants, it has lots of the links already in there for the carbon data, for the fisheries data, but also links to all the papers. And it's an open access paper, so it's available to have. But yeah, that's maybe an okay starting point to look at different global data sources. But as we talked about with the other question, then it might be also useful to look at individual data sources. But it's also the global data set's globally consistent, whereas different countries may use different approaches. So there's also trade-off with these things.
Yeah, yes, I see. Thank you.
Yeah, good. So next questions from Sigit Febrianto. Could you please turn on your camera so you can interact with the speaker?
Okay,
Yes.
thank you. I will ask from Thomas. Good presentation. What satellite data is used to estimate mangrove carbon? Optical data or just combination with radar and etc. Thank you.
Yeah, so it depends on the approach. So there's lots of different approaches. So on the whole, they're often split into soil carbon approaches and above ground carbon approaches. So above ground carbon, probably the most recent one is the data from Mark Samard and colleagues at NASA, who created that global height map, and that was based on LiDAR and DEM data to work out the height and the basal area weighted of each tree within a pixel. And so you get the biomass and then you convert that to carbon. For the soil carbon, it's often modeling approaches that model measurements of soil carbon relative to important environmental variables. So that may be geomorphic setting, it may be mangrove condition. I think the Sandeman paper uses some of the Landsat data and correlates it to that and does a relevant forest. So it really depends on whether you want soil carbon or above ground carbon, and also on the paper itself. There's been a lot of interest in how you measure carbon within mangroves. They are carbon rich, so it's been seen as an important thing to look at for ecosystem services. So it really does depend on the author's approach, but often they're correlative. So there's some field data that's used to create a model of that versus environmental settings and so forth.
Okay, thank you.
Okay, thank you. So based on the schedule, we still have 3 more minutes. If there is, Kaisar, yes, please, Kaisar. And next, yeah, please, Kaisar.
Yes, thank you for your presentation, Thomas. So my question is about the mangrove, especially in Indonesia, because I'm in Indonesia. So based on the data and the global data, as we know, is the Indonesia, especially in the mangrove area, is really high in the fishing pressure. So in 2020, we mapping about the area, especially in critical land, for the left fish pond area, and we want to map about the restoration area or the rehabilitation area in Kalimantan, but the approach is not quite work, because some area is not possible. Like we see in the imagery, it's possible, but when we go in the field and then we take the UAV photo, it's not possible. Is there any approach that maybe in Mr. Thomas or work have been done before for the restoration, and also the management, because some area in Indonesia is full with indigenous people, and yet we cannot just do the restoration like we want to do. Maybe in some cases in other Southeast Asia have other approach for that. Thank you.
Okay, thank you. So I'll deal with the second half first. So I think, you raise a really important point that, involving local communities and indigenous people is incredibly important within restoration. Lots of the work that we do is kind of at the global scale and really pointing to areas that may be restorable, but until we go to the field and sort of identify what's the underlying kind of socioeconomic settings, political settings behind that, the restoration is purely just on a map. So, I think that's a really good important point. In terms of mapping aquaculture, there have been a number of attempts to do that. I think there's some work by Clark Labs to try and identify globally where aquaculture ponds are. And that might be a good starting point. One other area is trying to identify areas where the aquaculture ponds are no longer being used, and because that would be a very good starting point to restoration. But I think there is quite a lot of efforts to produce global maps of aquaculture, particularly kind of pond aquaculture. I haven't seen anything finally published, but maybe there's some stuff in Clark Labs that did do it for certain countries. I can't remember whether it was Indonesia, I'm afraid, but there is potentially some things there.
Yeah. All right. Thank you. Tom, we still have three person who want to ask. You don't mind if
no,
is that mine?
No,
okay.
no.
Okay. First, please Anggia. I saw you raised your hand first. Please Anggia, and then Wayan. After that, Narjas. Yeah, please Anggia.
My question already taken by the others.
Oh, okay. Okay then.
Okay.
So next, Wayan, please Wayan.
Okay, thank you, Mr. Yaya. Thank you, Dr. Tom. This is a valuable presentation from you, and also valuable information regarding the mangrove monitoring using your tools, maybe. In Indonesia, we actually have developed the Monmang. Monmang is an Android app. Smartphone app. Is available in both in App Store and also Android. And maybe I wondering that if we embed the tools, maybe the tools from World Mangrove, from the ocean world, something like that, from your tools to Monmang, how could I do that? Maybe we need some discuss or talk later about this, or I can just put the link of your tools to the Monmang. Thank you, Dr. Yaya.
Yeah, I think that's a really interesting question. I think in terms of the Global Mangrove Watch data set, the people developing it, we're trying to get it as user-friendly as possible. I'm not sure how well it works on phones currently, but it's all available online, so all that information. So I guess the question is how best to link the two things. And we're really thinking over the next kind of year, 2 years about how we can get more local scale data within there. So there may be opportunities to try and link those two things together. But yeah, it'd be good to hear about your app and how it works and what kind of information it captures. Because I think there was a question earlier on about how good is this global scale data for local scale stuff. Well, if we start to have local scale stuff, we can start to try and see. And And I think I said earlier, one of the most challenging bits for this is like the training of data. So if people are going out and collecting training data, that's really useful for us to sort of make the global models better. You know, I think what would be excellent is if we had like a two-way street. So we're trying to provide this useful global analysis that maybe help local implementation, but you're also providing local data that helps improve the global data. You know, that kind of data moving backwards and forwards. And I think we're getting to a place now with like tools and data storage where we can start to think about that. We're not quite there yet, but we're moving in that right direction. So yeah, that's a really interesting point. Thank you for that.
Oh, thank you. Maybe next time we will provide a button in Monmouth, and if we click that button, and they will be go to your site, maybe like that, something like that. Yeah. Okay. Maybe we will discuss with you later. Thank you.
Yeah, that will be good. Okay. Next, Narjas, please.
Hello, can you hear me?
Yeah.
Yes.
All right, great. My name is Narjas. I'm a recent environmental science graduate. First, I'd like to thank Dr. Thomas for this really insightful and informative presentation. I learned a lot. So I'm not sure if this question is relevant, but I was wondering, because I think a lot of the approaches mentioned are sort of applicable on areas or locations with an up and running mangrove restoration project or areas that have research to build up on. So I was wondering for locations or projects that are just starting or have a lack of data, those type of areas, what type of data or research should we be focusing on recording and mapping? If that's a relevant question.
Yeah, it's a great question. Thank you. So within the tracker tool, what we're trying to develop is a kind of framework where you go through and you say, you know, these are the questions we need to record. We can't capture in detail everything just because things differ between different projects, but you know, it will start to be a good process for looking at, you know, what information is key when we're thinking about restoration. So we set out things like, really simple things like, you know, where is the location? It's amazing, lots of restoration projects don't record that information. But if we know where that is, we can do remote sensing to see where it's changed over time. But like, who are the partners? What led to the mangroves being declined? You know, the plan for the data capture is that it can work, you know, on projects that are happening now, projects that are happening in the future as an idea, but also projects that happen. So it's getting an overview of where restoration is. So there's no real barriers to it. You know, we understand that not everybody is going to be able to collect all the data. You know, there's quite a lot of questions in there, but you know, we're just trying to capture as much as possible. And as people do use the tool more, I think it's hopeful that, you know, more people will start to collect more bits of data because, you know, we're trying to showcase why that's important. So hopefully, you know, that will stimulate, oh, well, actually, this is a useful thing to capture. It'd be good if we could do this. But we do understand that, you know, there's a time and a cost to data collection. So we're not asking people to go out and collect extra data. It's, if you have the data, please put it in. So, but if you're interested in the project, please do reach out. We're happy to help.
So I was wondering if we were to reach out with the tool, would it be through a website or should we email you? Or...
Drop me an email. Hopefully, yeah, please just drop me an email. Show it's working.
Great, thank you very much.
All right. We still, maybe this is the last questions we have, Tom, is that okay? Yeah, the last questions from Anggia, please, Anggia.
Hello, I'm Anggia. I'm from Anambas. I'm working in Marine Affairs and Fisheries. I'm working in Marine Protected Area in Anambas. In here, mangrove is not one of priority in local government and people here, not priority. And but here is Marine Protected Area, but so what do you suggest us to do something with mangrove in here? Thank you.
Okay, I guess it really depends on what the pressures are on that mangrove area as to kind of what the best approaches are. So I think there's lots of good information on the Global Mangrove Alliance website about best practice approaches if restoration or conservation are the key aims. And I think we're trying to build that kind of information up in terms of what science is available and what kind of guidance is available for those approaches. So it really does depend on what you want to achieve, what's the aims of the project, but also what's the pressures, kind of this kind of often most importantly, what's the socioeconomic drivers and conditions there.
Thank you.
All right. Maybe that is the last questions we have this sessions. Well, Tom, I'm really happy today having you here. Really appreciate for you and you can deliver the presentations. It's very useful. It's very valuable. The information, the knowledge, and we hope we can still collaborate in any ways. Right? It's not only not only in these sessions. Maybe after that. Yeah. Before you leave, maybe you want to say something as the closing talk, and don't forget to please to share the PowerPoint to us. Yeah. Yes, please, Tom.
So I just like thank you for the opportunity to speak this morning or this afternoon, wherever we are in the world. It's been really nice to meet everybody, and thank you for the really great questions. As I said, I think there's loads of work going on in this field at the moment. So things are changing quite rapidly, more information is becoming available. But as I also said, it's a really friendly group of people. I've had lots of good interactions with people. So, reach out to people and, if you're interested in collaborating. The Global Mangrove Alliance has lots of good information. And the Global Mangrove Watch, which I'll send a link to, it's got some good data in. And yeah, if you have further questions, please do just drop me an email. But it's been really lovely to speak to you this morning. So thank you, and enjoy the rest of your course.
Yeah, thank you, Tom.
Thank you.
Oh, there is a request from Pak Wayan to have a photo session, please. Siapa? Mbak Tami? Ya, silakan Mbak Tami. Who takes photo, Pak Wayan?
Wait a moment.
Okay, you will do it?
Yeah.
Okay, please. Okay,
we start from, we have 2 pages. Okay, we start from the page number 1. Please turn on your camera. Okay. 1, 2, 3. Wait a moment. We move to the next pages. Next page. Sorry. Okay, 1, 2. Okay, turn on your camera. Okay, Wanda. Okay, 1, 2, 3. Okay, thank you very much, Mr. Yaya.
Okay, thank you. Thank you again, Tom.
Thank you.
Thank you very much.
Thanks. Bye.
Yeah, bye.
Okay. Okay, this is okay. Thank you, Tom, and also thank you, Dr. Yaya, for this afternoon session in Mangrove Monitoring International Training 2021. This is the end of our sessions today.
Okay.
So I would like to remind that please download all of the materials for tomorrow from the LMS, so that you don't need to learn how to download tomorrow. So we will focus to training for tomorrow. So tomorrow we will begin in the morning at 8 o'clock. It's PM GMT +7. Maybe there is any comment from participant or Dr. Yaya or the others committee, maybe some announcement.
I'm enough.
Enough. Okay. Thank you very much for everyone today. This is the end of the session today. Thank you very much and see you tomorrow.
See you.
Thank you, everyone. See you
you.
tomorrow.
Thank you.
Bye.
Thank you.
Okay.
Bye.
Thank you.
Thank you.
Thank you, Pak Wayan, Pak Yaya, and all.